The story of my life, I take her home. I drive all night to keep her warm in time.
A market analyst working for a small appliance manufacturer finds that if the firm produces and sells X blenders annually, the total profit is P of X equaling 8x plus 0.3x squared minus 0.0013x to the cube minus 372.
Here's the flowchart for the solution of the problem. First, you need to arrange the polynomial in descending order. Then, write down all the factors of the constant term of the polynomial. Write down the factors of the leading coefficient, that is q. Write down all the possible values of p of q, and then use the syntactic division and the general formula to obtain all the values of pq. If the remainder of the synthetic division gives you 0, then it's a factor of the polynomial. If it's a factor of the polynomial, then you have the remainder roots. Therefore, you obtain the zeros of the polynomial. Take out the end behavior, so how does the graph moves. Once you have all of these, then you make graph and you can know the answers. The first question tells you to put the point where the manufacturer wins money. Blenders, in this case, the point is 2423.0. This is the point where the graph tells you that you don't win nor lose money. The second tells you to put the range in which you win and you don't lose, and then to see which is the highest amount of money you can win and the blenders that can be sold. That it will be explained later with the graph. Now that we have all the flow chart, we know how to do. We know how the graph will behave. So we need to make the synthetic division between one point that we know, as is point A. Now it's 25.23, yes? So we need to do the synthetic division and give you 0. So we know that this is 0 of the chart, of the graph. Now with the factors, we make the general formula of polynomials, so to give us the other two zeros, that will be this. Now we now can graph the points which the company would have to make the break even.
We may see that point A, which is one of the zeros of the polynomial P of X, is going up, saying that X, the number of blenders, is winning Y, the money. You can sell without losing or winning money, but since you can't split a blender, you have to round the quantity. In this case, the manufacturer needs 25 blenders to break even. Point E in our graph is a maximum point, meaning that that value is a maximum number of blenders we can produce and sell without losing money.
In conclusion, the problem taught us that if this manufacturer wants to win money, they have to sell more than 25 blenders, but less than 166. Otherwise, they will lose money rather than winning it. We can apply the resources learned in this problem and learned through all first partial in daily life. In this case, we can use as an example all the companies that sell things, because they can see whether they are losing or winning money. We can also apply these, for example, in presidential elections, so we can see which president is winning in our ratings, so we can see which are the grades we have to improve, and also in the incomes and outcomes we have in home. Hope you enjoyed this video.